Find the x and y intercepts, the vertical asymptotes, and the end behavior. Then use this information along with a sign chart and a couple of additional points to sketch a graph of h of x equals x cubed minus 2x squared plus 16 all over x minus 2. Now first we'll look for the y-intercept. We know that the y-intercept occurs when we evaluate the function at 0. When we do that, all of the terms with x's will become 0, and we'll be left with 16 over negative 2, and 16 divided by negative 2 is negative 8, so the y-intercept is y equals negative 8. Next, for the x-intercepts, we have to figure out where the numerator equals 0. So this is x cubed minus 2x squared plus 16 equals 0. This is not something that we know how to factor straight off the bat. So what we're going to have to do is use the rational zeros theorem to figure out a 0 so that we can begin factoring this. Now, we know that any rational 0 will need to be a factor of 16 because the leading coefficient is 1. So the potential rational zeros are plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. This is going to be quite an intense problem with checking different zeros, and I don't want to make this video too long, so I'm just going to go to the one that I know is a 0, which in this case is negative 2. So let's show this with synthetic division. We've got 1, negative 2, 0, and 16. So we bring down the 1. 1 times negative 2 is negative 2. We add to get negative 4. Negative 4 times negative 2 is positive 8. We add 0. We multiply by negative 2. And we end up with 0 in the end. So we know that this polynomial can be factored into x plus 2 times x squared minus 4x plus 8, and that equals 0. We can't actually factor x squared minus 4x plus 8 easily because there are not two integers that multiply to 8 and add up to negative 4. So we'll have to use the quadratic formula to see if there are any zeros that come from this polynomial that will end up being an x-intercept. So we can try and solve x equals the opposite of b, which is 4, plus or minus the square root of b squared, which is 16, minus 4 times a times c, all over 2 times a. And if we look under the radical, we're going to have 16 minus 32, which is negative 16. And we know that the square root of a negative number is imaginary, so there are no real roots. And what this means is that x squared minus 4x plus 8 are not going to contribute any more x-intercepts. So the only x-intercept is the one that we got earlier, which is negative 2. So we've got x equals negative 2 as an x-intercept and y equals negative 8 as a y-intercept. Next, let's move on to the vertical asymptotes. We know that these occur when the denominators equal to 0. And since the denominator here is x minus 2, we need to see when x minus 2 equals 0. And of course, this occurs when x equals 2. So we're going to have a vertical asymptote at x equals 2. We've got an x-intercept at negative 2. We've got a y-intercept at negative 8. We also want to look at the end behavior. If we look at the degrees of the numerator and denominator, the numerator is 2 degrees higher than the denominator, which means that we're going to have no horizontal or slant asymptotes. And so we need to look at the ratio of these two terms to to figure out the end behavior. X cubed over x is x squared, so the end behavior acts like x squared, specifically going up in each direction. So we've got the x and y intercepts, we've got the vertical asymptote, we've got the end behavior. We're going to need a sign chart and a couple of additional points to sketch the graph. What I'm going to do is I'm actually going to draw my own xy plane because we're actually going to need the y-axis to go up further than we would on the graph paper that I have provided in the past. So first, I just want to split up the x-axis. We know that the important x values are -2 for the intercept and +2 for the asymptote. So we've got +2 for a vertical asymptote, and we're going to have -2 for an x-intercept. So -2, -4, -6, 2, 4, 6. Let's go in and make our sign chart. So when we do this, we have x plus 2, x squared minus 4x plus 8, and we also have x minus 2. The only critical numbers are at -2 and 2. So x plus 2 is going to be positive so long as x is greater than -2 and negative otherwise. Let's skip to x minus 2 for a moment. This will be positive so long as we're greater than 2 and negative otherwise. And then finally, x squared minus 4x plus 8. We're going to use a little bit of logic here. Remember that this had zeros that were complex numbers. This means that this graph, if we were to graph y equals x squared minus 4x plus 8, would not intersect the x-axis. So if we have a parabola opening upwards that doesn't intersect the x-axis, that's always going to have to be positive. So this factor is always going to be positive no matter what the x value is. Another way that you could determine that is you could use transformations of functions. You could complete the square and you could graph this, and you'll get a parabola that's always above the x-axis, so we know that the function value here will always be positive. So once we have our sign chart made, we can go through and see that our function values will be positive, negative, and positive. So I want to start actually by looking at the rightmost interval from 2 to infinity. We know, this is positive, we know that we're going to be positive on this interval. So we know that we're going to be staying above the x-axis, and we know that we are asymptotically approaching this vertical line, and then also the end behavior looks like x squared. So on the right, we're going to be going up, looking kind of like a parabola. But we don't have a single point over here to figure out how far we go down. So what I want to do is I want to actually plug in a function value. We could plug in, let's say 4, and figure out exactly where this graph is going to go. So let's evaluate h of 4. If we do that, 4 cubed is 64 minus 2 times 4 squared. 2 times 16 is 32, and then plus 16 all over 4 minus 2. 64 minus 32 is 32, plus 16 is 48, and 4 minus 2 is 2, and 48 divided by 2 is 24. So we're going to have a point at 4, 24. And the reason I haven't labeled my y-axis yet is because I didn't know how high we would need to go. So I'm going to go by 5s here. 5, 10, 15, 20, 25, 30, 35, 40, and then I'm going to do the same as we go below. If I had used the same template here that I did for the last problem, which only went up to about 15 or so on the y-axis, we wouldn't actually be able to graph this part of the graph. That's why I waited. So we know we have the point 4, 24. That's going to be around here or so. So our graph we can draw like this. So we know that we are asymptotically approaching this vertical line here. And then off to the side, we know that we have end behavior like x squared. So we're curving upwards. Now let's look between -2 and 2. On this interval, our graph is going to be below the x-axis. Our function's negative. And we also had a y-intercept of -8 that I forgot to plot. That's going to be right there. And so if our graph is going to be below the x-axis, it's going to go through these points, and it's also going to be asymptotically approaching this line, we know that it's going to have to be something like this. And then finally, for the leftmost interval, we know that we're always going to be positive, and we know that our end behavior looks like an upward opening parabola, so it's going to look something like that. And so this is a rough sketch of the graph of h of x equals x cubed minus 2x squared plus 16 all over x minus 2.